Today we're going to talk about mole concept. But before we touch deeper to understand mole concept, you need to understand the word mole. Now some of you will be thinking it must be the animal that dig holes in the ground. No, I'm not talking about that. Or you say, oh, I know it must be a mole on people's face. Moly, moly, moly. No, stop it. No, it's not. Now, mole actually represent a number. Let's say I have a pair of shoes. If you look at the word pair, you always register the number 2. If I have a dozen of eggs means that I have 12. A dozen of donuts also means that I have 12. So what does a number represent? What is the number that will represent mole then? Well, 1 mole actually represents this number. It represents 6.02 times 10 to the power of 23, and we actually call them Avogadro's number. Imagine today I say I have 1 mole of pens. Means that I have 6.02 times 10 to the power of 23 numbers of pens. Imagine I have 1 mole of donuts. It means that I have 6.02 times 10 to the power of 23 number of donuts. And what if I have 1 mole of basketball? If I have 1 mole of basketball, I actually have 6.02 times 10 to the power of number of 23 number of basketball. Do you know that this number of basketball can fill up the entire earth? Well, that is a beautiful number, 1 mole, okay, or mole. Now, you will be thinking, what has it got to do with mole concept? Stay with me. So I'm going to give you another scenario. So let's imagine together with me right now. I am drawing a weighing scale. And I place a tiny little piece of feather on it. Now, this feather will sit nicely on this weighing scale. And you're supposed to measure what is the mass of this feather. And you look at it, hey, Miss Selina, nothing, 0. The weighing scale spoiled. Then you change another one and still look at it and it still registers as 0. You say, all the weighing scale are spoiled. Or you will say, I will write 0.000. No. It didn't register any mass. It's because the feather is way too light. So if it's too light, they couldn't register it. What is another way for you to measure the mass of 1 feather? Well, you can actually take a basket full of feathers, place it on this weighing scale, and then if you know that inside perhaps you have 1,000 feathers, you will register 1,000 feathers equals to maybe whatever mass. And because you know the mass and you know the number of feathers, you divide it, you will find the mass of 1 feather. Well, similarly, it is impossible, relatively, or I should say it is very hard to measure the mass of 1 atom. We all know atom is the smallest unit of all matter. So how do you measure it then? Well, that's why we came up with mole. If I say I have 1 mole of hydrogen atom, I actually have 6 times 10 to the power of 23 numbers of atoms. And not only that, if I say I have 1 mole of hydrogen, 1 mole of hydrogen actually has a mass of 1 gram. And how do I come up with this? Well, from the periodic table, you know that hydrogen is 1, 1. The number below represents your relative atomic mass. So if I say 1 mole of hydrogen is equivalent to 1 gram, then it makes sense now. Since I can't measure 1 atom, I can measure 6 times 10 to the 23 number of atoms of hydrogen, and that will give me 1 gram. Let's bring it further. How about oxygen? Oxygen, 1 mole of oxygen actually has a mass of 16 grams. I take reference to the number below, and they are the relative atomic mass. So 1 mole of hydrogen is 1 gram, 1 mole of oxygen is 16 grams. How about 1 mole of H2O then? How much gram is that? You notice that there are 2 atoms of hydrogen. So that will be 1 times 2 plus 1 oxygen is 16. That will give me 18 grams. There you go. The 1 mole allow us to quantify the measurement of all the different elements and compound, because we can actually now finally measure it using a weighing scale, and it becomes useful. So next time when people say 1 mole of something, you'll remember the number 6.02 times 10 to the power 23. And that allow us to take measurement of the mass into account. Next up, I'm going to explain to you relative atomic mass.